This is section 11.6, and then also 5.1 and 5.2 combined. As we start to talk about now using that standard deviation that we found over the last few days, our objective here, there's two of them. We're going to interpret the standard deviation, figure out what that means, and then we're going to use the normal distribution to identify percentages of data. Okay? So, standard deviation and normal distributions. Standard deviation is actually a measure of the typical amount of entry, okay, that it deviates from the mean. How far is the typical amount of data entries away from the mean? Okay. The more the entries are spread out, the greater the standard deviation. And I've given you three examples down here from a graphing standpoint. You'll notice again here on this first example, the mean is 5, okay? And the standard deviation is 0. So as you look at this, you'll notice all the data points are at 5. This is how many times 5 came up. Notice nothing else came up, which means the standard deviation is 0. That means everything is exactly at the mean. Okay? In terms of the next one, this time, again, the mean is 5. The standard deviation this time is 1.2. That means that some of your data points are going to be away from your mean. Not every point's going to be at the mean. And you'll notice the mean is bigger than everything else, but there are still points that are just a little bit away from the mean. Okay? And you'll notice the third one, the mean is still 5, and the standard deviation this time is 3. So the standard deviation is quite a ways away this time, and you'll notice how many points do you have in here that are in the mean? There's none. The bigger the standard deviation, the more spread out your points are. Okay, the more farther away from your mean the data points are. And you'll notice this one has a lot of data points away from the mean. Okay, so that should be able to help you kind of understand a little bit in terms of standard deviation, in terms of a graph and what that means and how it works. Okay, now we're going to interpret the standard deviation. Okay, so we're actually going to use the standard deviation here and understand more or less what it means. A normal distribution, okay, normal distribution is typically called a bell curve. And you'll hear the words normal distribution quite a bit. Okay, it's distributed normally. That means essentially it's distributed evenly, and you'll understand what that means when we start to look at examples. Most of the values fit in the middle of the overall data range. Okay, we talked about finding range from the highest to lowest. So anytime you have a normal distribution, most of the values fit in the middle of that. Fewer values are on both the high and low ends of the range. Okay, so you get the farther away you get from the average, the less the numbers are. For example, this kind of gives you a better idea. Sometimes an example will do that for you. If we all sprinted 100 meters, okay, think about it. If everybody in our class sprinted 100 meters, there'd be a few people who would be very fast. There'd be a few people that were very slow. But most people are going to be somewhere in the middle. Okay, that's essentially what normal distribution is. Okay, so the properties of a perfect normal curve. The mean, the median, and the mode are all equal. They're all the same. They're in the exact center of all the data. Okay? The normal curve is bell-shaped. It's symmetric on the right and the left. That means symmetric on the right and the left means if I cut it down the middle, the right half and the left half are going to be exactly the same. We've talked about in the past. This is something that's very, very important, and that is the area under the curve is exactly 1. This means that every single data point fits inside the curve somewhere. Okay? The area under the curve is 1. That's going to be very important to remember. The curve approaches but never touches the x-axis as it gets further away from the center. Okay? So it never touches the x-axis ever. All right? Okay, so there's some more characteristics of a normal distribution. Okay. All normal distributions obey what we call the 68, 95, and 99.7 rule. 68% of the observations are within one standard deviation of the mean. 95% of the observations are within 2 standard deviations of the mean. And 99.7, which means pretty much almost everything except for 0.3%, are within 3 standard deviations of the mean. Okay. This is what the graph will look like. You'll notice you see your bell curve here. There's the bell curve. Okay. You'll notice you have the mean, which is exactly right in the middle. Okay, the mean's in the middle. That means it's the average. The right half and the left half are exactly the same. So what they're saying is this is one standard deviation away from the mean. That covers 34% on each side, which is 68% total. So 68% of your data is between one standard deviation, positive and negatively, away from the average. Okay. If you look at two standard deviations away, from two standard deviations away, it's going to be 95% of the data. The 68 plus another 13.5 on each side, that gives you 95% of the data, which is almost all of it. Okay? And then if you're three standard deviations away, then you're really looking at a majority of your data. That's 99.7. That means these two little spots out here are 0.3%. They're very minute. Okay, so a normal distribution has a symmetric bell shape centered on the mean. The mean or the average is always in the middle. Okay, that's another part that's very important. Okay, so here's a little bit better example kind of to see here and talk about this as we write down here, because you're going to get some examples here in just a second. We're going to go through these. Now, again, this is a standard normal curve. Okay, again, remember, your mean is always in the middle, so you'll see this as x bar. That's the mean. It's always in the middle. Okay, one spot away from the mean is if we take the mean and we add one standard deviation, or we take the mean and we subtract one standard deviation. Okay. The next line is if we take two standard deviations and we subtract two standard deviations from the mean. The third one is if we add three standard deviations or we subtract three standard deviations. So you'll notice the further you are from the middle, the less points there are. Okay, the closer you are to the middle, the more points there are. All right. So you'll notice again, if you take one standard deviation, you add the 34 and 34. Or let's say I wanted to do the right half. The right half would be very, very, very close to 50%. It's not going to be exactly 50%. It's going to be very, very close. Okay. All right, let's take a look now at the examples down here. It says, in a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States ages 20 to 29 was 64.3 inches, with a standard deviation of 2.62 inches. Estimate the percent of women whose heights are between 59.06 and 64.3 inches tall. Okay, so as you're looking at this, you see the bell curve down there. The first thing you want to do is you want to put in the middle the mean. Okay, so I'm going to put the average in the middle, and the average or the mean is 64.3. That's right here. Okay, 64.3. That is the mean. Now, it says the standard deviation is 2.62. So what I'm going to do is I'm going to take 2.62 and I'm going to add it with 64.3. And if I take 64.3 plus 2.62, I end up with 66.92. That's one standard deviation away on the positive end. If I subtract 2.62 from 64.3, that gives me 61.68. Okay, so all I did was take 64.3 plus and minus one standard deviation. Now, if I add another 2.62 to these values, it's going to give me two standard deviations, which is 69.54. And if I add another 2.62, this is 72.16. Now, if I take this value and I subtract 61.68 and I subtract 2.62 more, this is 59.06. And if I subtract 2.62 more, this is 56.44. Okay? Now, what it wants to know, the question is asking, what percent of women whose heights are between 59.06 and 64.3. So I'm going to go on my normal curve, and I'm going to look. Okay, here's 59.06 right here. Here's 64.3. I want to know what the percentage is of people that are in between those two values. Well, I've got 13.5% plus 34%, which if I add those two together, that gives me 47.5%. So 47.5% of women are between 59.06 and 64.3 inches tall. Okay? So in this case, all you're doing here is you're putting in your mean, adding in and subtracting in your standard deviations and figuring out, okay, how much percentage is it from one point to the next? Using, again, these numbers. Okay, one more example here, or two more examples here as we look at this. Okay, it says the scores of Algebra 2 final, on the Algebra 2 final, are approximately normally distributed with a mean of 150 and a standard deviation of 15. Now, you'll notice you got a lot more generic curve this time. These are the kind of curves you're going to see more often. Okay, so again, what I want to do here is I'm going to draw a line through the middle of my bell curve. That, again, always goes through the middle is the mean, and the mean is 150. Okay, so one standard deviation away from 150, it says the standard deviation is 15. So one standard deviation away from 150 is going to be 165. Two standard deviations away is going to be 180. Three standard deviations away would be outside of that. Okay, so let's talk one standard deviation away on the other side. One standard deviation away from 150 is going to be 135. Two standard deviations away is going to be 120. Okay? So, as we look at this, now that I have this here on the graph, I'm going to move this up and I'm going to answer the question. It says, what percentage of students who took the test scored above 180? So you look at your normal curve, you're looking above 180, so I'm looking to the right of 180. Well, again, this is 34% on both sides. Okay? This is 13.5% here and 13.5% here. And then outside of that is 2.35%. Well, for students who are above 180, that's going to be 2.35% of the students that finished with above 180. You look at your chart, greater than 180 is here and to the right. Okay? And that's what we'll be able to do. Now, the next example is kind of interesting because it says if 250 students took the final, approximately how many scored above 135? So again, as you look at your chart here, right here's 135. I want 135 and above. So if I add 34, 34, I'm going to add 34, 34, 13.5, and 2.35. If I add all those together, those percentages, because that's how much percent of the people that got above 135. If I add all those up, that's 83.85% of them. But I want to know how many scored above it, not just the percentage. So 250 took the test. I'm going to take that times the percentage of 0.8385, and that will give me how many out of those 250 scored above 135, which if you calculate that, you get 209 students. So 209 students out of the 250 scored above a 135. And if you think about this, 83% of this number, 250, that's a majority of it. Okay? 209 is pretty close to 250 when you calculate that out. Okay, so these are the kind of questions you're going to be looking at with your normal distribution, your standard deviation, and being able to calculate percentages, and also be able to find how many on average. This concludes section 11.6, standard deviation.